This course is designed to provide you with a comprehensive understanding of cloud computing. You will learn the fundamentals of cloud computing, various cloud service models, and how to secure cloud-based systems and data. Let's review the course outline of what you will be learning. Module 1: Introduction to Cloud Computing and Cybersecurity. Understanding cloud computing models. Security implications of cloud adoption. Key cloud security challenges. Module 2: Cloud service providers and security. Overview of major cloud service providers. Shared responsibility model. Security features offered by cloud providers. Module 3: Identity and access management in the cloud. Authentication and authorization in the cloud. Role-based access control. IAM best practices. Module 4: Data security in the cloud. Data encryption and key management. Data classification and protection. Data loss prevention in the cloud. Module 5: Network security in the cloud. Virtual private clouds. Network segmentation and isolation. DoS protection in the cloud. Module 6: Cloud compliance and governance. Regulatory compliance. Cloud security frameworks. Auditing and monitoring. Module 7: Security for cloud applications. Secure development practices. DevSecOps in the cloud. Serverless security considerations. Module 8: Incident response and disaster recovery in the cloud. Cloud-specific incident response strategies. Business continuity and disaster recovery planning. Case studies of cloud security incidents. Module 1: Introduction to Cloud Computing and Cybersecurity. We will learn the following. Understanding cloud computing models. Security implications of cloud adoption. Key cloud security challenges. Introduction to cloud computing. Cloud computing refers to the delivery of various computing services, such as servers, storage, databases, networking, software, analytics, and more over the internet. Instead of owning and managing physical infrastructure, users can access and utilize these resources on demand from cloud service providers. Here are the primary cloud computing models. Infrastructure as a service. IaaS provides virtualized computing resources over the internet, including virtual machines, storage, and networking. Users can scale resources up or down as needed, making it cost-effective and flexible. Examples of IaaS providers include Amazon Web Services, Microsoft Azure, and Google Cloud Platform. Platform as a service. PaaS offers a platform that includes tools and services for application development, deployment, and management. Developers can focus on coding without worrying about infrastructure concerns. Popular PaaS providers include Heroku, Google App Engine, and Microsoft Azure App Service. Software as a service. SaaS delivers software applications over the internet, accessible via web browsers or mobile apps. Users can access these applications without installation or maintenance. Examples of SaaS applications are Microsoft 365, Salesforce, and Dropbox. Security implications of cloud adoption. As organizations move to the cloud, they must consider various security implications. Data security. Data stored in the cloud needs robust encryption to protect it from unauthorized access. Strong access controls and identity management are essential to prevent data breaches. Network security. Secure network configurations and monitoring are critical to prevent unauthorized access to cloud resources. Implementing firewalls and intrusion detection systems is essential. Compliance and legal issues. Different regions and industries have specific compliance requirements. Cloud providers may offer compliance certifications, but organizations remain responsible for their data's compliance. Key cloud security challenges. Moving to the cloud presents unique security challenges. Data privacy and ownership. Organizations must understand who owns the data and how it's used and protected in the cloud. Identity and access management. Ensuring only authorized individuals or systems can access cloud resources is crucial. Data loss and leakage. Protecting against data loss, whether accidental or malicious, requires robust backup and monitoring. Shared responsibility model. Cloud providers typically follow a shared responsibility model where they secure the infrastructure, while customers are responsible for securing their data and applications. Security monitoring and incident response. Effective monitoring tools and incident response plans are essential to detect and respond to security threats in real time. Vendor lock-in. Organizations need to consider the potential challenges of migrating data and applications from one cloud provider to another. Emerging threats. Cloud environments are susceptible to new and evolving cyber threats, so ongoing security awareness and adaptation are necessary. In conclusion, cloud computing offers many benefits, but it also introduces unique security challenges. To mitigate these risks, organizations must adopt robust security practices, implement strong access controls, and stay informed about evolving threats in the cloud environment. Module 2, Cloud Service Providers and Security. We will learn the following. Overview of major cloud service providers. Shared responsibility model. Security features offered by cloud providers. Overview of major cloud service providers. Amazon Web Services. AWS is one of the largest and most popular cloud service providers globally. It offers a vast array of cloud services, including computing power, storage, databases, machine learning, and more. AWS has a global network of data centers, enabling organizations to deploy resources in multiple regions. Microsoft Azure. Azure is Microsoft's cloud computing platform and is known for its strong integration with Microsoft products. It provides services for computing, analytics, AI, and IoT, among others. Azure has an extensive network of data centers worldwide and offers hybrid cloud solutions for seamless integration with on-premises infrastructure. Google Cloud Platform. GCP is Google's cloud offering, with a focus on data analytics, machine learning, and open-source technologies. It provides services such as Google Kubernetes Engine for container orchestration and BigQuery for data analytics. GCP also has a global presence, with data centers in various regions. Shared responsibility model. The shared responsibility model defines the division of security responsibilities between cloud service providers and their customers. Here's a basic breakdown. Cloud providers' responsibilities. Cloud providers are responsible for securing the underlying infrastructure, including data centers, servers, networking, and physical security. They also manage the security of the cloud services they offer, such as IaaS, PaaS, and SaaS. Customers' responsibilities. Customers are responsible for securing their data, applications, and configurations within the cloud environment. This includes setting up access controls, encryption, firewall rules, and monitoring for security threats. Security features offered by cloud providers. Cloud service providers offer a range of security features to help customers protect their data and applications. IAM allows organizations to set user roles, permissions, and multi-factor authentication to enhance security. Encryption. Cloud providers offer encryption at rest and in transit to protect data. They often provide key management services for secure key storage and rotation. Firewalls and network security. Cloud providers offer virtual firewalls and security groups to control inbound and outbound network traffic. Network security groups can be used to enforce network-level security policies. Logging and monitoring. Cloud providers offer logging and monitoring services to detect and respond to security incidents. These services can help organizations gain insights into their cloud environment security posture. Compliance and auditing. Cloud providers often provide compliance certifications and audit logs to help organizations meet regulatory requirements. Distributed Denial of Service Protection. Cloud providers have DDoS protection services to safeguard against malicious traffic that can disrupt services. Security tools and services. Many cloud providers offer security tools such as AWS Security Hub, Azure Security Center, and Google Cloud Security Command Center for centralized security management. Security best practices and documentation. Cloud providers publish extensive documentation and best practice guides to help customers secure their cloud deployments. In conclusion, major cloud service providers like AWS Azure and Google Cloud offer a variety of security features and services to help organizations protect their assets in the cloud. Understanding the shared responsibility model is crucial for effective cloud security planning, as it clarifies each party's responsibilities in maintaining a secure cloud environment. Module 3. Identity and Access Management. IAM. In the cloud, we will learn the following: authentication and authorization in the cloud, role-based access control, identity and access management best practices. Identity and access management in the cloud is a critical aspect of cloud security. Identity and access management involves managing and controlling access to resources and services in a cloud environment. Let's explore authentication, authorization, role-based access control, and identity and access management best practices. Authentication and authorization in the cloud. Authentication. Authentication is the process of verifying the identity of users or systems trying to access cloud resources. Common authentication methods include username and password, multi-factor authentication, and identity federation using external identity providers like Azure AD or Google Identity Platform. Authorization. Authorization is the process of determining what actions or resources an authenticated user or system can access. It involves defining permissions and access policies based on roles, groups, or attributes. Role-based access control. RBAC is a fundamental concept in identity and access management. It assigns permissions and access rights to users or systems based on their roles within an organization. Here's how it works. Roles. Roles are predefined sets of permissions that determine what actions can be performed on specific resources. Common roles might include admin, developer, read-only. Users and groups. Users and groups are assigned to roles based on their responsibilities or job functions. For example, a user in the developer group may have access to development resources, but not production ones. Resource permissions. Permissions are associated with specific cloud resources, virtual machines, databases, storage buckets. Role assignments determine which users or groups can access these resources and what actions they can perform. Identity and access management best practices. Effective identity and access management in the cloud requires following best practices to enhance security and manage access efficiently. Least privilege principle. Users and systems should only have the permissions necessary to perform their tasks. Avoid granting overly broad permissions to minimize the risk of unauthorized access or misuse. Regularly review and audit permissions. Periodically review and audit identity and access management policies and role assignments to ensure they remain aligned with business needs. Remove unnecessary permissions and role assignments. Use groups for user management. Group users with similar roles together to simplify management and reduce administrative overhead. Assign permissions to groups rather than individual users whenever possible. Enable multi-factor authentication. Implement MFA to add an extra layer of security. Users must provide multiple forms of verification password and mobile app code to access resources. Implement identity federation. Federate identities with external identity providers. Example, Azure AD Google Identity Platform for centralized authentication and improved security. Monitor and log access. Enable logging and monitoring of identity and access management activities to detect and respond to suspicious or unauthorized access attempts. Automate identity and access management. Use automation to provision and deprovision users and roles as needed. Infrastructure as code tools like Terraform or a AWS CloudFormation can help manage identity and access management resources programmatically. Regular training and awareness. Ensure that your team is educated about identity and access management best practices and security policies. Promote a culture of security awareness within your organization. Disaster recovery and backup. Implement backup and recovery mechanisms for identity and access management policies and configurations to prevent data loss in case of accidental changes or breaches. By implementing these identity and access management best practices, organizations can enhance security, reduce the risk of unauthorized access, and maintain efficient access control in their cloud environments. Identity and access management is a critical component of cloud security, and it should be continuously evaluated and updated to adapt to changing business needs and evolving threats. Module 4. Data Security in the Cloud. We will learn the following: data encryption and key management, data classification and protection, data loss prevention in the cloud. Data security in the cloud is of paramount importance to protect sensitive information from unauthorized access, breaches, and data loss. Let's dive into data encryption and key management, data classification and protection, and data loss prevention in the cloud. Data encryption and key management. Data encryption. Data encryption involves converting plaintext data into a ciphertext using cryptographic algorithms. In the cloud, data can be encrypted in transit while being transmitted and at rest while stored in storage services. Encryption ensures that even if someone gains access to the data, they cannot read it without the decryption key. Key management. Key management involves securely generating, storing, and managing encryption keys. Cloud providers offer key management services or hardware security modules to safeguard encryption keys. Key rotation and strict access controls are essential components of key management. Data classification and protection. Data classification. Data should be classified based on its sensitivity and importance to the organization. Common classifications include public, internal, confidential, and highly sensitive. Classification helps in determining appropriate security controls and access restrictions. Access controls. Implement strict access controls and role-based access control to ensure that only authorized users can access specific data. Use identity and access management to define and enforce access policies. Data masking and redaction. For sensitive data, implement techniques like data masking, hiding parts of the data, and redaction, removing sensitive content to protect confidentiality. Data leakage prevention. Implement DLP policies and tools to monitor and prevent the unauthorized sharing or exposure of sensitive data. DLP solutions can identify and block sensitive data in emails, files, or other communication channels. Data loss prevention in the cloud. Content inspection. DLP solutions inspect data for predefined patterns, keywords, or regular expressions to identify sensitive information. Examples include credit card numbers, social security numbers, and confidential documents. Policy enforcement. Create and enforce policies that specify how sensitive data should be handled. Policies can trigger actions such as blocking, quarantining, or alerting when violations occur. Endpoint protection. Extend DLP to endpoints such as laptops and mobile devices to prevent data leakage from devices. Endpoint DLP agents monitor and enforce policies on these devices. Cloud integration. Integrate DLP with cloud services, example, email, cloud storage to monitor data as it is shared or stored in the cloud. DLP solutions should support popular cloud platforms like AWS Azure and GCP. User education and training. Train employees on data security best practices and the importance of not sharing sensitive data inappropriately. Awareness can significantly reduce the risk of data leakage incidents. Incident response. Establish an incident response plan for dealing with data breaches or unauthorized data exposure. Define roles and procedures for containing and mitigating data loss incidents. In summary, data security in the cloud requires a comprehensive approach that includes encryption, proper data classification, and robust access controls. Implementing data loss prevention measures helps in preventing and mitigating data breaches and leakage incidents. Cloud providers offer various tools and services to aid in data security, but it's essential for organizations to understand their specific security responsibilities and take proactive steps to protect their data assets. Module 5: Network Security in the Cloud. We will learn the following: virtual private clouds, network segmentation and isolation, distributed denial of service protection in the cloud. Network security in the cloud is vital to protect your cloud infrastructure and applications from cyber threats. Here's a comprehensive overview of key concepts in cloud network security, including virtual private clouds, network segmentation and isolation, and distributed denial of service protection. Virtual private clouds. Definition: a virtual private cloud (VPC) is a logically isolated section of a cloud provider's network where you can launch and manage resources like virtual machines, databases, and containers. Benefits: VPs provide network isolation and segmentation, allowing you to create private and secure environments for your applications. They offer control over IP addressing, subnets, routing, and security groups. Key features: IP address management. You can define IP address ranges, CIDR blocks for your VPC, and allocate subnets within that range. Routing. You control the routing of traffic between subnets and to the internet. Security groups and network access control lists. These are used to define inbound and outbound traffic rules for resources within the VPC. Network segmentation and isolation. Network segmentation. Network segmentation is the practice of dividing a network into smaller, isolated segments or subnets. IT enhances security by controlling the flow of traffic between different segments based on defined rules. Isolation. Isolation ensures that resources in one segment of the network cannot directly communicate with resources in another unless explicitly permitted. It limits the blast radius of potential security incidents. Use cases. Common network segments include public, private, and demilitarized zone segments. A public segment might host web servers, while a private segment might contain databases that should not be directly accessible from the internet. DOS protection in the cloud. DOS attacks. DOS attacks involve overwhelming a target system or network with a flood of traffic, making it unavailable to users. These attacks can disrupt services and lead to downtime. Cloud DOS protection. Cloud providers offer DDoS protection services to mitigate these attacks. These services use traffic analysis, rate limiting, and other techniques to detect and filter malicious traffic. Key features. Traffic scrubbing. Cloud DOS protection services inspect incoming traffic and filter out malicious or unwanted traffic before it reaches your network. Rate limiting. Limit the rate at which traffic is allowed to enter your network, preventing sudden spikes in traffic. Anycast. Distribute incoming traffic across multiple data centers or points of presence to absorb DDoS attacks more effectively. In conclusion, network security in the cloud relies on concepts such as virtual private clouds, network segmentation, and DDoS protection. VCs provide a secure foundation for cloud resources, while network segmentation and isolation enhance security by limiting communication between resources. Cloud-based protection services are crucial for mitigating the risk of DDoS attacks, ensuring the availability and reliability of your cloud-based applications and services. Cloud compliance and governance are essential aspects of managing your cloud infrastructure while adhering to regulatory requirements and maintaining security. Let's explore regulatory compliance, cloud security frameworks, auditing, and monitoring in the context of cloud computing. Regulatory compliance GDPR GDPR General Data Protection Regulation. GDPR is a European Union regulation focused on data protection and privacy. It imposes strict requirements on how organizations handle personal data of EU residents. In the cloud, GDPR compliance includes data encryption, access controls, data breach reporting, and data protection impact assessments. IP, a Health Insurance Portability and Accountability Act. IPAA is a U.S. law governing the security and privacy of healthcare data. Healthcare organizations using cloud services must ensure compliance by implementing safeguards like access controls, encryption, and audit trails. Other regulations. Depending on your industry and location, various other regulations may apply, such as CCP, a California Consumer Privacy Act, FISMA Federal Information Security Management Act, or PCIDS Payment Card Industry Data Security Standard. Cloud providers often offer compliance certifications for these regulations, but customers are responsible for configuring their cloud resources to meet compliance requirements. Cloud Security Frameworks, CISNIST. CIS Center for Internet Security, Controls. CIS provides a set of best practices for securing computer systems and networks, which can be applied to cloud environments. The CIS controls cover areas like asset management, access control, continuous monitoring, and incident response. NIST National Institute of Standards and Technology Framework. NIST offers a comprehensive framework for cybersecurity that includes risk management, security controls, and incident response. NIST's guidelines are widely adopted in both public and private sectors and can be applied to cloud security. Shared responsibility model. Cloud providers typically follow a shared responsibility model, where they secure the infrastructure, while customers are responsible for securing their data and applications. Security frameworks like CIS and NIST help customers implement appropriate controls to meet their responsibilities. Auditing and monitoring. Auditing in the cloud. Cloud providers offer auditing and logging services that track user and resource activities within your cloud environment. These logs can provide valuable insights into security events and compliance status. Continuous monitoring. Implement continuous monitoring to track and assess the security of cloud resources in real time. Monitor for unusual activities, security misconfigurations, and potential vulnerabilities. Security information and event management. SIEM tools aggregate and analyze log data from various sources to identify security incidents. SIEM can help organizations detect and respond to security threats more effectively. Compliance audits. Regularly perform compliance audits to assess whether your cloud environment aligns with regulatory requirements and security best practices. Audits may include internal assessments or third-party audits for certification purposes. Incident response. Develop an incident response plan that outlines procedures for handling security incidents in your cloud environment. Test and refine the plan regularly to ensure it's effective. In summary, cloud compliance and governance involve adhering to regulatory requirements, implementing security frameworks, and establishing robust auditing and monitoring practices. Organizations must understand their responsibilities within the shared responsibility model and take proactive steps to ensure the security and compliance of their cloud infrastructure. Security for cloud applications is critical to protect your applications, data, and infrastructure in the cloud. Here's an overview of secure development practices, DevSecOps in the cloud, and serverless security considerations. Secure development practices. Threat modeling. Start by identifying potential security threats and vulnerabilities in your application. Conduct threat modeling exercises to understand where security risks may exist. Secure coding standards. Develop and enforce secure coding standards within your development team. This includes practices like input validation, parameterized queries, and avoiding hard-coded secrets. Penetration testing. Regularly perform penetration testing to simulate real-world attacks on your application. Address vulnerabilities and weaknesses identified. Code review. Conduct code reviews with a focus on security to catch vulnerabilities and issues before they make it into production. Least privilege principle. Implement the principle of least privilege to ensure that application components and users have only the permissions necessary to perform their functions. DevSecOps in the cloud. DevSecOps culture. DevSecOps is a cultural shift that integrates security into the DevOps process from the beginning. Encourage a culture of collaboration and shared responsibility among development, operations, and security teams. Automation. Use automation to incorporate security checks and tests into the CI/CD continuous integration, continuous deployment pipeline. Automated security scanning and testing help identify and remediate issues faster. Infrastructure as code. Implement security best practices in your infrastructure code to ensure that cloud resources are provisioned securely. Leverage tools like AWS CloudFormation or Terraform to define infrastructure. Immutable infrastructure. Promote the use of immutable infrastructure, where changes are made by deploying new instances rather than modifying existing ones. This reduces the risk of configuration drift and simplifies security updates. Continuous monitoring. Monitor application and infrastructure logs and metrics continuously to detect and respond to security incidents promptly. Serverless security considerations. Function-level security. Secure serverless functions by defining appropriate execution roles and permissions. Limit access to resources and ensure that only authorized users or functions can invoke them. Environment variables and secrets. Store sensitive data like API keys and database credentials securely using cloud providers' secret management services. Avoid hard-coding secrets in your code or configuration files. Dependency security. Regularly review and update dependencies in your serverless functions to patch known vulnerabilities. Use dependency scanning tools to automate this process. Cold start attacks. Be aware of potential cold start attacks, where the initial invocation of a serverless function may be slower. Implement appropriate security controls and timeouts to mitigate these risks. Monitoring and logging. Implement robust monitoring and logging for serverless functions to detect and respond to security incidents. Use cloud-native tools or third-party solutions for comprehensive visibility. In summary, securing cloud applications involves a combination of secure development practices, integrating security into the DevOps process, and addressing unique security considerations for serverless architectures. By adopting these practices, organizations can better protect their cloud applications and data in an ever-evolving threat landscape. Incident response and disaster recovery are crucial components of cloud security to ensure the continuity of your operations and protect against various threats. Let's explore cloud-specific incident response strategies, business continuity, and disaster recovery planning, and some case studies of cloud security incidents. Cloud-specific incident response strategies. Incident identification. Implement robust monitoring and logging in your cloud environment to detect abnormal activities and potential security incidents. Utilize cloud-native monitoring services and SIEM solutions for timely alerts. Incident classification. When an incident is detected, classify it based on severity and impact. Prioritize incidents that pose immediate threats to your critical assets. Incident containment. Isolate affected resources to prevent the spread of the incident. Cloud providers offer features like security groups and network access controls for containment. Eradication and recovery. Investigate the root cause of the incident, remediate vulnerabilities, and recover affected systems. In the cloud, use automation and infrastructure as code, IaaC, to rebuild or restore resources quickly. Communication. Establish clear communication channels and escalation procedures within your incident response team. Notify relevant stakeholders, including cloud service providers, if necessary. Forensics and analysis. Conduct a thorough analysis of the incident to understand its scope and impact. Preserve evidence for legal or compliance purposes. Business continuity and disaster recovery planning. Risk assessment. Identify potential risks and threats that could disrupt your cloud-based operations. Consider scenarios such as data center outages, natural disasters, or cyber attacks. Recovery objectives, RTO and RPO. Determine recovery time objectives, RTO, and recovery point objectives, RPO, to define how quickly you need to recover and how much data you can afford to lose. Backup and replication. Implement regular backups of critical data and applications in the cloud. Utilize data replication across multiple regions for redundancy. Failover and redundancy. Design your cloud architecture with redundancy and failover capabilities to minimize downtime. Use features like availability zones in AWS or availability sets in Azure. Testing and validation. Regularly test your disaster recovery plans to ensure they work as expected. Conduct tabletop exercises to practice response procedures. Documentation. Maintain comprehensive documentation of your disaster recovery plan, including step-by-step procedures and contact information. Case studies of cloud security incidents. Capital One data breach, 2019. A misconfigured firewall allowed an attacker to access sensitive customer data stored in an AWS-3 bucket. This incident highlighted the importance of proper cloud configuration and access controls. CodeSpaces shutdown, 2014. CodeSpaces, a code hosting and collaboration platform, was forced to shut down after a DDoS attack followed by unauthorized access and data deletion. The incident underscores the significance of robust incident response and data recovery planning. GitLab data deletion, 2017. GitLab accidentally deleted a production database, resulting in a significant data loss incident. The incident showcased the importance of data backup and restoration capabilities. These case studies emphasize the need for a well-defined incident response plan and robust disaster recovery measures in the cloud. Each incident underscores different aspects of cloud security, from configuration errors to data loss prevention and DDoS protection. Organizations can learn valuable lessons from these incidents to better secure their cloud environments and respond effectively when incidents occur.